This is the first whiteboard explanation of the titration experiment, experiment 11. You have videos for this. I'm going to use the data from the videos to go through this, but the actual data you're going to be given is going to be different. So make sure you don't use the data from the video to do the calculations. All right, so titration is a technique where you are going to determine, it's the determination of the amount of a substance by the reaction with a measured amount of another substance of known concentration. And my colleague demonstrated the technique. So the ultimate goal of this experiment is actually for part C. Part C, what you're going to do is you're going to be given an amount of hydrochloric acid and you don't know the molarity. All right, so molarity is question mark. You're going to react it with sodium hydroxide, which will of course form sodium chloride and water. All right, here you'll have a molarity and you're going to measure a volume, and then you'll have a volume and a molarity, and then you can use this to get to moles. Get to moles of this. You'll know the volume, you're going to use 10 mils. Now the problem is I need the molarity of the sodium hydroxide. All right, but from the molarity and the volume of the sodium hydroxide, the volume you'll measure, you can get the moles of the hydrochloric acid. You take the moles, you divide it by 10 mils. The problem is that sodium hydroxide, so in part A, you're actually not going to do this, but you're told to make 300 mils of 0.10 molar sodium hydroxide from the solid. Now the problem with sodium hydroxide is it's a deliquescent solid. And we've worked with that before. It absorbs water. And so the problem that you would have if you actually did this is weighing it out is very difficult because it's going to absorb water as you weigh it. In addition, sodium hydroxide comes in pellets, and so it's hard to weigh it very precisely. If you're trying to get good precision here and you can't make it very precisely, then you run into problems. And so basically the idea is that part B, which is the first one you're going to do calculations, you're going to be asked to do this calculation, but you're not going to actually make the solution. Part B, what you're going to do is you're going to standardize the sodium hydroxide. And the way you standardize is you titrate it against, we use the word against, but you're going to react it with a standard. And a standard is simply something that you can determine the number of moles very easily. And there's a whole bunch of them, but the standard we're going to use is oxalic acid dihydrate. So it's a hydrated solid, and it's a solid acid, which means you can get very good precision. Make sure that you use this molar mass in your calculations. All right, just to help you with that, this is about 90, water is 18 times 2, 36, and 90 is 126. And the idea here is that you'll take oxalic acid that we have weighed out for you. It'll be reacting with sodium hydroxide, and you'll get sodium oxalate and, of course, water. And the idea is you'll take the mass of this, and then you can get to moles. You're going to measure a volume. And then from the mass of this, you can get the moles. Then you get the moles of sodium hydroxide. Moles divided by volume will give you the molarity. Whoops, let's make that look like an M. And that molarity is that molarity. All right, so I'm going to stop this video here, and then I'm going to do two more. One where I'm going to do the part B, and one where I'm going to do part C. So there will be 3 videos. This is the general video. One other thing before I go into the other part. When we do these reactions, the trick is, how do I know when the reaction is over? And the reaction is over, we're going to use, and it's mentioned in the video, we're going to use an indicator. And the indicator in this case is phenolphthalein. There's a bunch of different indicators. All it does is it changes color when the reaction is over. And how does it know? Phenolphthalein is a very weak acid. Sodium hydroxide is a base. Sodium hydroxide will react with any acid in the solution. It'll react with the strongest acid first, so it'll react with oxalic acid. When the oxalic acid is gone, it'll react with the phenolphthalein. When the phenolphthalein reacts, it changes color, and that's how we know it's over. Interestingly, if you let these sit for a while, if you just have a little bit of excess sodium hydroxide, water in the flask will react with carbon dioxide in the air to form carbonic acid. Phenolphthalein is pink in sodium hydroxide. But if there's no sodium hydroxide, it's not pink. Carbonic acid, that first reaction is very slow, will react with sodium hydroxide. Whoops. And it'll form sodium carbonate and water. But the idea is that the phenolphthalein is pink because of this. So if you let it sit for a while, the phenolphthalein will fade because of this reaction. All right, so now I'm going to go through the calculations in 2 separate videos. So let me go ahead and stop this one. This is video number 1. The other ones will be number 2 and number 3.